previously distributed in the body. If primitive chondrites are melted, two immiscible liquids will form. A metal liquid, which is much denser than the silicate liquid, so the metal liquid will sink to the gravitational center of the body and form a metallic core. The silicate liquid will rise toward the surface and eventually crystallize into a silicate mantle and a silicate crust. This is very similar to oil and water, as we see here at the bottom left. Oil and water are immiscible. They do not dissolve with one another. Oil is less dense than water, so if we have a mixture like this that reaches equilibrium, the oil will float to the top of the liquid and form a scum at the top, and the water will be beneath. Meteorites that were melted in their parent bodies suffered separation of their metal and silicate. Metal sinks to the center, silicate floats to the center and to the top. And these rocks are said to be differentiated because there are different layers in such a body. These meteorites, the stony meteorites that are differentiated, are the achondrites, which means they do not contain chondrules. We have an example of a no chondrule sign over here at the left, and as a differentiated stony meteorite here at the bottom right. Differentiated meteorites come in three basic varieties of stones, which are mainly basalts. They're from the crusts of melted and differentiated bodies. There's the irons, that consist mainly of metallic iron-nickel alloys, most of a vignette-shaped structure due to subsolidus cooling. And most of these iron meteorites are pieces of the cores of differentiated asteroids. Finally, to the main topic of today, we have these stony irons. These are mixtures of metallic iron, nickel, and silicate rocks. There are two main groups of stony irons, which we will discuss today, the pallasites and the mesositerites. When we differentiate a planetesimal or asteroid like this, we may get sort of pods of liquid, as we see here on the left. As the asteroid continues to melt, the metallic liquid will sink to the gravitational center of the body to form a core. The silicate will crystallize into the crust and mantle.
Everybody who believes in God should have piece of this.
The first type of differentiated meteorites are the stones.
The stone inside your DNA.
By crystallization from a magma.
Meteorite from space.
Crust diogenites, another form of differentiated stony meteorite. They form in the upper mantle. The picture here is of the Nilma lily eucrite from Australia. We have the iron-nickel phase diagram here. At the very top, L stands for liquid. At these very high temperatures, all the metal is in liquid. As
white gold, white
diamond. Liquid cools, it begins to crystallize, and we get this gamma phase, that's taenite, at high temperatures. When we reach the solidus down there at the bottom, sort of right over here, the metal, the taenite will start forming a low nickel phase, and as expects, the alpha phase, which is camosite, and so camosite and taenite will crystallize together as both become richer nickel. As more and more of the low nickel phase camosite precipitates from the original taenite crystal.
DNA in these stones.
We will get a vignette-shaped structure.
You never know now, you know.
This is the subsolidus intergrowth of the two iron-nickel
meteorite beer,
low nickel phase camosite and high nickel phase taenite. The camosite grains occur parallel to the four sets of octahedral planes within the parent taenite crystal. If we cut the octahedron here and different faces, we will get
God lend me these stones to bless you all with.
Here's the picture of the Henry 3AB iron meteorite. Iron meteorites constitute discrete groups, discrete chemical groups. Each is derived from a separate asteroid.
Only one man got that.
From one another.
That's me.
They're both chemical compositions. If you look at the diagram here, this